Okay. Now we're recording. First thing I want to point out about the ongoing homework 1, the MATLAB tutorial. I've started using this page on the site, the questions page. So as I get email questions, then and answer them, then I'll post questions and answers here. So a couple of you might recognize your question. You might want to. It'd be a good idea to check there first in case your question is already answered. Right now there are only, two each with multiple parts. Does anybody, so this is on the questions link on the course site. Does anyone have any homework 1 difficulties?
I have a question about
Number 12. Okay, let me get that up on screen here. Oh, yeah, this one is definitely one of historically, not that there's much history here, but poses difficulties.
My question would be, so I know that the matrix you do transpose, you just do apostrophe on
Hang on. Need to find the volume control on here. Oh, okay. Sorry, I had difficulty hearing, but.
I know that we talked about whenever you just do a transpose, the default is automatically Hermitian transpose,
Right.
transpose and the conjugate.
Yeah.
Which is why it makes a difference on your imaginaries.
Yeah.
So that's what we're looking for, where you do one with just apostrophe versus apostrophe dot to see the difference in where they do. I saw transpose versus that's Hermitian, right? That H.
Yeah, the H is a Hermitian
So
transpose.
is that what I'm kind of trying to gear myself towards? Is looking at how they react with just an apostrophe versus
Okay. Problem 12 is okay. Sorry, I can't seem to find a volume. I was using volume control last time. Oh, it's on the Yeah. People down on the coast, I'm having difficulty hearing questions asked up here. Okay, so even though this problem is located in the MATLAB section, it does actually not require MATLAB to do. It's something that can be worked out on paper. So what I would suggest is, since it's asking for a some non-zero vector, so you can make one that's very simple, like something that has 2 elements, for instance, and you would carry out this operation. So just a straight dot product without any complex conjugation. Because what will happen is, it'll just be easier for today to type in here, since I'll be in here anyway. Okay. Yes, it started. Yeah. Thanks to everyone for jumping on that. Okay, so it's basically a dot product with or without conjugation. So I'm going to just make an example of a complex vector. So I'll have, let's say, 1 plus I and then 2 plus 3I. So if I have Z Hermitian transpose Z, so that would be, so this vector 1 minus I, 2 minus 3I so conjugated, dot product with 1 plus I, 2 plus 3I. And what will happen in that case is you're going to have
numerical analysis, which is 460 numerical analysis.
all right. So you'll end up having this times this plus this times this, and anytime you multiply a complex number with its own conjugate, you're always going to get a non-negative real number. So in general, z times z conjugate is equal to the modulus or absolute value of z squared. So if z is equal to a plus bi, so this is your complex numbers crash course for those of you who've forgotten it. So the absolute value of z squared is always a squared plus b squared. So if I resume this, okay, I'm going to copy this down here. So it's going to turn out to be 1 plus, so minus 1 times 1, so minus I times I is also 1. And then we have 2 times 2, and then minus 3I times plus 3I is 9. Okay, so you end up with 15 in this case. So that's what happens when you do Hermitian transpose, when you do perform a conjugation. But now suppose you don't. Then you no longer have that guarantee. Yeah. And this is one of those things where when you have the notion of a magnitude of a number or a function or anything like that, because the absolute value can be taken to be defined as like the square root of x squared, and a lot of people just cancel the square root and the square and think, oh, it's x. Well, actually, it's not. It's the absolute value of x. So, and a lot of times when you need to account for a possibility of complex numbers, it's necessary to include that conjugation so that you have a reasonable notion of magnitude. Because whether you're dealing with real entities or complex valued entities, if you want to know their magnitude, that should always be a non-negative real number. So having the conjugation ensures that. Okay. Other questions? From up here or down there?
Hey, those stuff that you write or I wrote throughout the time we do class, can we see back those stuff on our
Wait, so like this stuff or something else?
like all the stuff that you write since I wrote since we started class.
Well, all of that.
Suppose we want them for reference or stuff like that.
Yeah, that's right here. Any materials from class, any files, or is posted on the lectures page by the next day.
So the text would be what you have written.
Yeah. Yes.
Okay.
Yeah. So, for example, during this MATLAB tutorial, the last couple classes, and continuing this week, the diaries. So what I typed in the output is in here, the diary. Whereas, like on the first day of class, I had those LaTeX notes, and that's what I'll have most times, except for this tutorial. And then the M files that were involved also. So yeah, lectures page for all those things. Okay. All right. Other things? Yeah. Sorry. Which thing?
MATLAB.
Okay.
Yes, sir.
Yeah. All right.
I have a question about number 5. You said to use the ones function to create the random matrix.
Oh. Hold on. Let me jump to. Are you still?
No.
Okay. Number 5. Oh. Not absolutely necessary. And actually, something I did in class indicates how it's not necessary. But yeah, it could be used as part of it. Yeah. Other questions?
Number
11.
is that something you want done by hand or wait, well, is it
Oh.
done by like that? Does it require a script or can you just do it in the command window?
Oh, so you can actually write, yeah, so it'd be a single MATLAB statement. That's something you could type into prompt.
Okay.
Yeah. And actually, that'd be a good idea. Like if you have a matrix there already, just demonstrate all that matrix. That way it's easy to check your result.
Like, so that would be a dot M? Is
Well, it doesn't have to be a .m. It just could be like it could be a part of a diary.
okay.
Yeah, definitely too small a job for a script. Anything more? Okay. All right. So, like last time, I want to get at least up to a certain point in a tutorial. It'll be finished on Thursday. So keep in mind that so this is good that you guys are making progress in the assignment since it's due in 1 week. Okay, but all the whole tutorial will be finished Thursday's class. Okay. All right. Now. Right. Now, so the next programming construct that we're going to look at, having seen if statements and for loops last time, is a while loop. So I have a file for that. Okay. Okay. Well, first I'm going to go ahead and run it. So the file is guessnumber.m. Oh, here's a handy command from time to time. So when the output is getting too cluttered on the screen, CLC will clear the screen. Now, all of this that I've just typed, that'll still go in a diary. Okay. All right. Now, I run guess number. Sorry, what? Oh, sorry. Okay. Oh, unfortunately, the prompt is rather long. Okay. So, it outputs this prompt. I'm thinking of a number between 1... I should say between 1 and 10. That's horrible grammar on my part. What is it? Enter your guess. Oh, in the book it says and. Go figure. Okay. So, actually, the script in the book is slightly different, and the format is nicer, so I'm going to fix it. I'm going to move this part up here. So that's not part of a prompt. It's just going to display that statement. And then on the next line, it's going to solicit the guess. Okay. Oh, forgot to put the and, whatever. I'll fix it later. Okay, so I'm just going to pick a number between 1 and 10. I really have no idea what number MATLAB is thinking of, so I'm likely to get it wrong. Okay, so what's going to do is I keep typing in numbers. Oh, bad example. Let's do that again. This is horrible randomization. Okay. I'm trying to illustrate some iteration here. Okay. That's more like it. Wow. Now I'm really horrible at guessing. very last option. I went through everything. Okay. Well, so what happens is it's going to keep asking me to, or actually going to keep yelling at me and telling me to enter number between 1 and 10 until I have a match. So the thing is, as we see from these several examples, this one I had to guess 10 times. The other times I was guessing twice. So it's an indefinite number of iterations. Just because the number is chosen randomly, we don't know how many times this iterative process is going to run. And that's what a while loop is helpful for. A for loop, these are not absolute, but a for loop is most often used when there's a definite number of iterations to perform, like for I equals 1 to 10. A while loop is when there's some uncertainty about that. So you want to keep loop to keep going as long as some condition is true. Once the condition is false, the loop will terminate. So here's an example of a while loop. So first, we'll talk about the other lines here. It's going to pick one random number, so you can think of it as like a 1 by 1 matrix. Now that number is going to be between 0 and 1. So now I'm going to scale that by 10. So now I have a double precision floating point number that's somewhere between 0 and 10, although it's not going to be, I think it's not possible for it to be exactly 0, but it could get very close to 0. And then I call this function ceil, short for ceiling. Now, you may have come across this elsewhere. What does a ceiling function do to a number? Also comes up in computer science. Yeah, it rounds up. Yeah, so it's also known as the there's floor and there's ceiling. So floor will round down to the nearest integer. Ceiling will round up to the nearest integer. If the number is already an integer, it just stays the same. So like a floor function is also known as the greatest integer function. It's the greatest integer that's less than or equal to x. So we have floor and ceil because I want, because I don't want 0, I want a number between 1 and 10. So rounding up will accomplish that. So number is not going to be an integer between 1 and 10. So now I print my prompt. I take the number. So guess is the number that I've typed in. So now I have this while loop. So we have a keyword while and then a condition. So the loop runs as long as the condition is true. So let's suppose the number that it's thought of is 2, and I input 5, so they do not match. So since the number is not equal to the guess, the loop will execute. So what happens inside a loop? It yells at me and then wants the next number. So now guess has been changed to the number I've typed in. So what will happen is it'll go back up here. This condition is re-evaluated with any with whatever current values may be. So number has not changed. That's what it was at the beginning. But guess is my latest guess. So as long as I have continued to guess wrong, it's just going to keep asking me. And the way I've written this loop, it could go on forever. Like if I'm going to be stupid about it, and even though I have only 10 options, but I keep going back to other ones, so I couldn't really let this run forever if I didn't really care to get it right. But if I guess a different number each time, then yes, this loop will run at most 10 times, and sure enough, that's what happened. So once the condition is false, the loop will exit, and then control passes down here to whatever statement follows the loop. So here it prints that message, and I finally got it right. Okay. So any questions about what's in this code?
Whenever you're doing this guess equals input, and you have just a statement that's being displayed.
Yeah.
So it's taking whatever you're inputting, after that statement is displayed and putting it into guess, correctly?
Yeah.
So how does that work with
Oh, I mean, like how is this assigned to
Yeah.
guess?
Yeah, like how it's
Okay, so I'm not sure. Actually haven't used the input statement very much, except for cases where what is intended to be input is just a single number. But what any function like this has to do, since what I'm typing is just going to be coming in as raw text, so it's going to have to perform some sort of interpretation there and try to figure out what type of object it is to assign it to guess. And I'm going to try something. Okay. Well, let me go ahead and clear this. So, I'm pretty sure I've never done this before. I'm going to give it non-numeric input. Ah, okay. I have a hunch about what it's doing. So right now, from a code I've run previously, my guess is 6. Okay, so now I'm going to do this again. Ah, okay. Now, that was enough for me to figure out how it behaves. I could have also looked at the help page, but what fun would that be? It takes whatever I type and evaluates it as if it's something I typed at the prompt. So guess is a variable name in my workspace over here, whereas I just made something up before, a variable that's not defined. So whenever I type it, it just evaluates the expression, and then that is the value that's stored in whatever variable you put here. Yes.
With the guess function, what happens when you do not put in anything? You just simply press enter.
Probably.
It tells me, I don't know if I've got something wrong, but it tells me I guessed right.
Empty matrix. I think it had to be something like either 0 or an empty string or something like that. But yeah, so you give it nothing, it just gives you a 0 by 0 matrix.
Right, but then the guess number dot m it says I guess correct.
Yes, mine is too.
Oh, sorry, what?
So if you just run the previous function that we had, for guess number,
Yeah.
and then you just have no
Oh, I see.
value inputted, then it says that your blank space right there is equivalent to
Oh, that's freaky.
yeah.
Okay.
I guess because there's no clause for a non.
So in that case, guess is an empty matrix.
Yeah.
So then if I look at this Boolean expression, guess not equal to number. Okay, a 0 by 0 logical array. Okay, because it's comparing a number to an empty matrix.
Yeah.
And because it's empty, it considers it true. That's a little odd. And they probably had to agonize over that to decide what should be the truth value of an empty matrix. Not sure what to make of that, to be honest. But yeah, but this is a good illustration of how while loops behave. That because the result of this expression, for reasons I still can't fathom, is true. Its value of this expression is false. It will skip over and execute the code that follows. But yeah, well, let's do this then. Since this comparison was for a purpose of evaluating a while loop was judged to be true, if I do the same thing here of equals equals testing for equality, that result is the same. So probably that would have been considered false too. I think if it's something that just doesn't make any sense. But I think that's what happens when for a language that's as permissive as MATLAB is. That you can try to compare anything. Okay, but here. Okay, here's what I can do. A certain type of function I want here, and I'm not remembering the exact name of it, but I think I can find it here. Okay. Oh, that's not what I want. Okay. So here's what I can do. I would want to make sure that what is typed in is numeric. So here's a function called isNumeric. So if A is a numeric array, like it could be a scalar or vector or a matrix, but at least I'm confirming that there's numbers in there. So in other words, if I do isNumeric on an empty matrix, it still says true? Wow. I do not like that. On some level, I get it, but I'm opposed to this. But here's okay. But I don't want this to happen. I don't want the loop to be skipped. I don't want to come down here and say you guessed right if I give it an empty matrix. I want to prevent that behavior. So here's what I can do. So I could say I want the number of elements in guess to I want it to be equal to 1. So if it's not equal to 1, like for example an empty matrix, and then I need so if either one of these conditions holds, I want it to solicit another guess. So I would put an OR in here. So if I get something that's not just a single number, bless you, or if it is a number but it's not equal to guess, it should ask for another guess. So let's see if this works. Because I'm breaking one of the first rules of teaching. Anything that's improvised is almost guaranteed to go wrong. But, okay. Alright, so I'll type in nothing, and sure enough, it does not treat that as correct. So it's going to keep insisting that I give a number. Okay, got it on 2 tries. Well, 2 tries that mattered. Okay, so now what is this function numl? I need to explain that. That is for any data structure. This is number of elements. So it's a total number. For instance, if it's a matrix, it would give you the number of rows times the number of columns. So however many numbers or elements of any kind are in this, bless you, is what it would give. So I need it to be just 1 because I want to be looking at just a single number. And what I would probably best do is have an additional condition that making sure that one element is also numeric. So that'd be an ideal situation. Because what if I somehow fed this data that's one element, but of a different type, like a character or something? It needs to be a number. Okay. So if any of these things happen, not one element, like an empty matrix, not numeric, or not equal to the correct number, it's going to want another guess.
When you say number of elements, do you mean how many digits, or you mean if it's numerical versus alphabetical?
Oh, I don't mean digits.
I mean whether it's
Entries.
numerical or
Like entries of a matrix, for instance. I have a 3x2 matrix. Number of elements would be 6.
okay.
Yeah.
Okay.
Yeah.
Good.
Okay. All right. Other questions? All right.
we do previously, if you didn't put something in that was numeric?
Oh, sorry, what?
If I previously, before you put that not in numeric.
Like, okay, this situation had not yet come up in anything I've tried, but let's suppose I had a variable, like, because we've already seen how if at this prompt I type in some variable name, it evaluates that variable.
Oh, okay, that's what you're saying.
Yeah, like, suppose I had a variable that's equal to a character.
Yeah, that makes sense.
Yeah, it would slip by this. But I would hope that this would be false then. I'm not going to try right now because I'm not prepared for MATLAB to disappoint me further than it already has. Yeah. Other questions?
Can you tell me again why you put that middle is numeric? Yes.
Oh, that's what I was just explaining.
Okay, I was thought you were talking about the elements.
Oh, no, yeah. So one element, but not numeric.
Okay.
Yeah. Okay. Any other questions? Alrighty. Alright, so now I have another script that illustrates a while loop. This one's much more mathematical. In fact, it deals with material that's going to be covered toward the end of the semester. So this file is called Newton square root.m. So it uses a method that we'll cover much later called Newton's method to compute the square root of 2. So it's a relatively simple iteration that really can be adapted to compute the square root of any number. So what I'll do is I'll take you through this code, explain what it does, and then I'll go ahead and run it. Okay. So what happens is this is an example of what's called an iterative method. So it's a method that it has a starting value. In this case, the starting value or initial guess is 1. And this iteration is going to keep improving that value to try to get it closer to this desired value, which in this case is the square root of 2. It'll never get to it exactly, but it's going to keep getting closer and closer. So once we decide it's close enough, the iteration will stop. Okay, so I can display a message that it's going to compute the square root of 2. And I'm going to have this while loop that carries out the iterative process because I don't know up front how many iterations are going to be needed. So now this is rather unusual, and in fact, that should be a apostrophe. Okay. Okay. Well, at least that's fixed in the book too. This is actually convenient, although not necessarily well-advised approach to while loops, because I've mentioned that a while loop will keep going as long as the condition that's put here is true. Once the condition is false, then the loop terminates. So how is this loop going to behave because I put in while true? What does that mean for the loop continuing or stopping or whatever? Anyone hazard a guess?
As long as it's true, it's going to continue to
Yeah. So when will this loop stop?
remember it's false.
But I put in true. Is true going to become false?
It needs to be assigned to
Well, it doesn't have to be. You can put anything here. It's a constant. What?
When you get to a certain degree of accuracy, or
That's going to be taken care of down below. But if I have a loop that says that it's coded this way, while true, and while loops are meant to keep going as long as whatever you put here evaluates to true, and while loops stop when this expression turns out to be false. But since I put true here, what does that say about this loop ending? It never will. I've just created an infinite loop, which is not something you want to have. Fortunately, as I'll explain, there is a provision for this loop ending. It's just not going to happen from here. But I wrote this way because it was convenient. But actually, one of the homework problems is about how would you modify this so that it doesn't require an infinite loop. So I'm not going to give that away here. Okay. now, so how does this loop actually proceed? Okay. So I have an x value coming in. Initially, it's 1. So what I do is I'm going to save it in another variable called old x. And the reason for that is I'm going to determine whether to stop by looking at the latest x value and the previous x value. I need 2 on hand. So I'm saving the old one, and now I'm going to overwrite x with an updated value. So this formula here carries out the iteration. So if x is some approximation to the square root of 2, however poor it may be, it will improve that approximation. Now, how this iteration does that is not something I'd expect you to see or understand at this point. But when we get to chapter 10, Newton's method, and so when I show you that, then you'll be able to see why this iteration works. So once it's updated, it's going to display the new value. And now I need to check whether I can stop. Okay, so what I do is I look at the difference between the two in absolute value, and then I check whether it's less than this threshold. So the 10 to the minus 15th times the absolute value of x. So this is actually what's called a relative error. So absolute value of x minus old x divided by x. I want that to be less than 10 to the minus 15, which is pretty much the smallest I could reasonably expect it to get due to round-off error, for reasons that'll become clear in chapter 2. So if this condition is true, and x would have to be x and old x have to be really close to each other for it to be less than this, because of how small 10 to the minus 15th is. So if those iterates are getting closer and closer to each other, then I'm assuming, and correctly in this case, that all those values are getting really close to the square root of 2. Because the error in my approximation should be going to 0. So once it happens, it's time to quit. So I use a break statement. So what does a break do? A break can be used inside a while loop, like this one. It can also be used inside a for loop. I just didn't show you that last time. What happens is a break statement causes immediate exit of the while or for statement that is immediately enclosing it. So for example, if this while loop was enclosed in a for loop, this break statement would quit the while loop, but the for loop would continue. So it only quits one loop. Okay. So this is why it's not really an infinite loop, because there is a provision for exiting it. But the thing is, this would only work if I am guaranteed that this iteration of mine is going to converge. Now, in this case, I happen to know that it will, so it's not an issue. But if you're not sure, you may want to take some steps to make sure that the loop will stop. For example, many iterative methods, like real implementations of them, like ones that MATLAB themselves implement, they will impose a maximum number of iterations, maybe like 200 or something like that. So that way, whatever loop is never going to be infinite. Okay. And actually, I think it's, one of the homework problems involves that, is modifying this code to impose a maximum number of iterations and change a while statement accordingly. So once it's done, after the break statement, we exit the while loop. So now we're down here. So we're just going to display the result, what x is. And then, just to confirm that it's correct, it's going to go ahead and square it and display that, because that should be, if not equal to 2, it should be really, really close to 2. Okay. All right. So any questions about this code before I run it?
I have a question.
Yeah.
On the last 2 or 3 lines, you got display the square root of x. I mean the square root of 2 is, and then you have the, what is that x right there?
Because I don't have a semicolon, anytime you put a variable in a line by itself with no semicolon, it will print that expression out.
Okay.
Now, disp will do it too, but the formatting is different. And I'll show you when I run. Other questions? All right. Okay. Newton's square root. Okay, so a lot of the output flew by. So what happens is, okay, it says what's going to happen here. The first guess was 1. That's the initial guess that I set. And then it keeps improving the approximation. But what I should do here, before I run it again, I'm going to do format long. Because I want to see more decimal places. Here, all these approximations look the same, but really they're not. Okay, that's better. So we have 3 halves and 17 twelfths, and then it keeps going. And we see that these decimal places are not changing, like the ones to the left. There's still some change going on here. But notice these 2 iterations, the last 2, at least the 15 decimal places, are identical. So the difference is going to be less than 10 to the minus 15th, because here we actually have 1, 2, 3, 4, 5, 6, 15 decimal places. So the iteration stops. So it outputs the final value, which matches what's here. And then we square it, and yep, it essentially is 2. And there's a little bit of round off error in there, but for all practical purposes, it's 2. And what we see is the iteration converges pretty quickly. So after 1, 2, 3, 4, 5 iterations, it got square root of 2 correct to 15 decimal digits. So Newton's method is a method that, under the right conditions, converges very rapidly. And whereas we'll see other methods that are not as fast, but they might be more reliable, for instance. Okay. So here's about the printing. So these values, the iterates, were printed using disp. Also, this last one here. This one was when I had that line x by itself. Notice it says x equals. It gives the name, whereas these don't. And yeah, there's definitely a good reason to use either one, depending on the situation. Like, you actually want to see your variables as you're trying to get your code to work. You want to just go ahead and put it without a semicolon. But if you want the output to look a little more professional, like control the appearance of the output, maybe not have it as cluttered, or taking up so much space, all these blank lines, then disp is a good idea. Actually, one thing I've done, like when I'm writing research papers, so I'm using LaTeX for that. How many of you use LaTeX? Probably not very many. Oh, more than I expected, actually, so that's really good. So, because I've had my results in MATLAB, and I want to put them in a LaTeX table. So what I will do is I will write disp statements like these that will generate the LaTeX code for the table. So then, if I need to update my results, I can just run that, and the table itself is automatically updated. So then I can just copy and paste that into my document. Okay, so it's saved me a lot of time. Well, writing that code to make the LaTeX statements, that's tedious at first, but it saves me a lot of time later. Okay. Any other questions about this script? Yes?
So, in MATLAB, we format long as to 15 digits.
Right.
Is earlier, whenever you were talking about your code, you did less than 10 to negative 15.
Yeah.
Is that a coincidence that MATLAB uses the same? Because you said you did that because of Newton's, right?
I'm guessing that it's not a coincidence that they chose format long to have that many decimal places. Now, because one thing we'll learn about in Chapter 2 is what's called like machine precision, or also known as unit round-off, it's the smallest number that you can add to 1 and still get something that is considered greater than 1. So anything smaller than that, the floating point system would still say it's 1. And that number is actually it's 2 to the minus 52, which is okay. So a little smaller than that, so 10, on the order of 10 to the minus 16. So pretty much 10 to the minus 15-ish is like the most accuracy you could expect to get.
So anytime we're running any kind of code where we're trying to get some type of margin of error,
Yeah.
some weirdness, approximation, that's what we should use most of the time.
Well, actually, I would not use anything smaller than that. That itself may still be too small. Because sometimes when if I have something that generates error that's supposed to be going to 0, and go to 0 at a certain rate, once it gets down around 10 to the minus 12 or so, that expectation starts to peter out because there's an accumulation of round-off error. I would actually say be happy if you even get 10 to the minus 8, like the square root of that. So if you do get if you get better than that, that's a bonus.
The first 2 lines of the new.
Oh, this? Okay. Okay. That reminds me, I want to try something here. I'm going to see if I formatted right. Okay, so here I used MATLAB's help command, but I used it on my own file, Newton square root. And it actually had some help. Where does it get this? It's the comments at the top. So if you have one of your M files, and you have comments at the top, then help applied to your file will print those comments. So anything up to like a blank line, so it stopped there. So for instance, if I made this line not blank, let's see what it would do. Oh, yeah, it would pull that in also. So it takes first lines of comments up to the first non-comment statement or blank line, and that's your help. So this is important. Like if you have code that you want other people to use, that should be documented fairly. Then you should put comments at the top, so then they can do help on that and actually get help. Okay. Any other questions?
So wait, do we want that
What?
percent sign there? Or
No. I was just doing it so you can see how it would behave. Yeah. Alrighty. All right. Okay. Now every single M file that I've shown you today and also last time, those referred to as script M files. So that's one kind of M file. The other kind is a function M file. So I'm going to show you the first one of those. A very short one. So then I'll be able to explain to you how you can write your own functions in MATLAB. Okay. So here's a function M file, convert temp. So what it does is, actually, I can do help on this one also. So here, there were no comments at the very top, but there are comments after the first line that describes the function, so it'll use those as a help. So this function is a very simple job. It takes as input numbers that are interpreted as Fahrenheit temperatures, and it converts them to Celsius. and then the Celsius temperatures are returned. So I'm going to use this function once, and then I'll come back and explain what's happening in the code. All right, so convert temp. So I'll put in. So it expects a Fahrenheit temperature, so I'll put in boiling point of 212, and outputs the equivalent Celsius temperature of 100. I'll do it one more time. Put in a minus 40 for Fahrenheit temperature, minus 40 Celsius. That's the only temperature where Fahrenheit and Celsius are the same. Okay, so a little fun fact for you. So now let's take a look at how the code actually does that. So how you describe a function. So first you have a keyword function. So that tells MATLAB that this is a function M file as opposed to a script. So next you have any output arguments that the function has. Now you can have any number of output arguments. In fact, you can have 0 if you want, if a function is not meant to return anything to you for use later. So here I have one output, Tc, the Celsius temperature. If I have multiple outputs, then your output should be put in square brackets and separated by commas. I will have an example of that a little later. Okay, so, but here I have one output, so I don't need that. Equals, and then the name of a function. Now, the name of a function has to match the name of a file. Unfortunately, because of font, you may not be able to see that, but this file is called converttemp.m. Now, if these names do not match, when MATLAB calls the function, it uses the name of a file. Doesn't care what you put in here, but it urges you to match them just to reduce your own confusion. Then you have inputs. Inputs also are optional. If you do have input arguments, you put them in parentheses, and if you have more than one, like this function is only one input, one output. If you have multiple inputs or multiple outputs, separated by commas. Okay. So now we go through the computation, so subtracting 32 and then scaling by 5/9. Now the output is Tc, so that means Tc must be assigned a value. So whatever outputs you have here, make sure they're assigned a value, or you're gonna get an error message somewhere. Okay. Now one other very important detail. This variable temp. Now, it's assigned a value here that's used down here, but the variable temp is only known inside the function. Now, for those of you who are more computer sciencey, MATLAB does what is called call by value. So whatever parameter is passed in, if that is changed in here, that does not take effect outside this function. So in other words, whatever value I passed as TF, a copy of it is made. That is what is used in here. So it's not destructive in that sense. Whereas some other languages, like a lot of languages, support both pass by value or pass by reference. So a copy is made or not. So that you can change something in here and it does take effect outside the function. But MATLAB does not do that. So when this value is assigned to temp, this variable temp only exists inside the function, and once the function exits, temp is gone. Now, one consequence of that is, if I have a variable here, temp, just coincidentally, so I'll just give it a value, something like that. Well, that y shouldn't be there. So there's my value temp. So if I call convert temp with 212, well, 212 comes in here. I subtract 32 from it to get 180. And here, temp is going to have a value 180. So let's call the function. And now look at temp. Still has a value that it had before. So this temp, even though it has the same name, is completely independent, in a different place in memory than this temp here. So another way of putting it in MATLAB's own terminology, a function has its own separate workspace. Here at the prompt, it says workspace here. It has all my variables and their values. So you have your top level workspace here for doing things at the prompt. Anytime you call a function, a new workspace is created for a function to do its work. Once a function exits, the workspace goes away. So in other words, whatever names you give your variables in here, you don't have to worry about whether they conflict with names out there because they're separate anyway. All right. The questions so far about
I have
functions?
a question about this one.
Yeah.
So basically, it's just 2 steps. You subtract 32, then multiply times 5 nines.
Mhm.
And so you're able just to make your tenth equal to that first step, and then you do your second step times the tenth to get your output. Right?
Yeah.
What if there's a third step in there? Would you have to update your value to,
Oh,
I mean, you understand what I'm trying to say? That
I'm not sure.
Function.
so you made, your tenth is equal to your Fahrenheit minus 32.
Yeah.
And then you just took that value and
Yeah.
multiplied times 5 nines.
Right.
So what if there was like a 3 or 4 step process? To update your value in any kind of way and assign it a different name, or
You don't have to.
Okay.
Yeah, you can use your variables however you like. Like you could, if you want, you could continue using temp if there's a reason to, or create more variables as needed.
so it automatically update each time it goes to each step.
Yeah. In other words, whatever value I've assigned it, it retains that value as there are more statements until I override it with something else. Like here, temp is 180. If I had more computations down here, temp would still be 180 until I said temp equals something else. Yes. So for the entire life of a function's execution, it retains whatever values. Is there a question down at the coast? All right.
Where do you write the function different from in the script? Is it somewhere different?
The only difference is that here, that you start with a keyword function. Now you're allowed to have comments up above, but yes. So the first bit of actual code, if it begins with a keyword function, it's a function M file. Otherwise, if you don't have that, it's a script. So one thing I want to point out is, suppose and remember, I want to emphasize, it has to be the first thing. Like, I'm going to put another statement up here just for fun, like x equals 1. And notice here on the right, I don't know if you can see it, it's become red. That's an error. MATLAB does not like me doing that. Because it looks like what I'm doing is trying to have a file serve as both a function, a script, and a function M file. Cannot do that. So if you have a function anywhere, you can't have code before it. Because otherwise it's ambiguous. Another rule is I am allowed to have other functions in this file, but they're called helper functions. This top function here is the only one that's known to the outside workspace. So I could have functions further down to help this one do its job. But they only exist for the sake of this function. I generally don't use helper functions. Sometimes I do. But it happens very often where I make a helper function and then I realize, oh, I need to be able to call this function somewhere else. So I would give it its own M file. So that's another important thing to keep in mind. So So really, it's literally the first word in the file that isn't a comment that MATLAB uses to decide what kind of file it is. Okay. Other questions? Now, the operations that are performed in this case, subtracting a number, scaling by 5/9, those work just as well performed on numbers as on vectors or matrices. In this case, it doesn't matter. So there's no implicit assumption that the output is just a single temperature. So, for example, if I make a random matrix, and so I'm treating these as my Fahrenheit temperatures, all pretty cold. Actually, okay, that's more like it. Well, actually, now most of these are pretty hot. So I'll do convert temp on A. So that will give me a 2x2 matrix of Celsius temperatures. And it's only because the operations I performed are defined for are well defined for numbers, vectors, or matrices. I could pass any of those things. Now, whereas if I passed this function like a TF being a text string, that would be an error because it does not know how to subtract 32 from a text string. So that would not work well. In fact, here's what I can do. I want to make sure that this has numeric data. So I'll do this. If whatever TF is not numeric. Well, actually, before I do that, I'm going to go ahead and call this function on, I'll pass it a text string.
Dr. Mathis, can you go to when you first called the temp function?
That? Okay.
Thank you.
Okay. Okay. When I do this, ooh, that's really weird. How did it do? Oh, I think I know what it did. It actually gave me temperatures. Okay. So somehow it managed to treat this as something numeric to work with. I wasn't really expecting that. Can anyone think of what it did?
Use the ASCII number.
Yeah, I imagine it must be that. So, for example, if I pass 65 for a temperature, okay, that's Celsius temperature. 65 is the ASCII code for an uppercase A. So, yeah. So it uses the ASCII code. That's disappointing. I wanted to produce an error message. Okay. Well, what I can do is I could try giving it something else. Okay. Let's see. Let's see. What would be something I was like, not only is non-numeric, but could not possibly be. Okay. This is an array of a cell array. Okay. Now I got an example that I could use. This, what I gave here, if this was square brackets, it would be a vector of characters. But when it's curly braces, it's what's called a cell array. A cell array is useful for storing objects that may themselves be of different types. So it's quite convenient. So MATLAB does not know how to subtract 32 from something like this, thank goodness, because I don't want to know what that would be. So it gives me this god-awful error message, undefined operator. So this is very, but it's kind of messy in terms of error reporting. So what I'm going to do instead is I'm going to say if whatever comes in is not numeric. Now, so a number, vector matrix, that's allowed, but something that it just doesn't know how to perform arithmetic on, even with an ASCII code, then I'm going to use this, the error function, to print out an appropriate error message. And what this function will do is it will exit the function, print out this message. So this is good for what they call idiot-proofing your code, to make sure that whatever input is provided is of a form that is expected. Okay. So now, if I go ahead and run that, it's a little cleaner here, so you're printing out this message. Okay.
Okay.
All right.
So if we just wanted to print an empty line, do we just put a semicolon?
Oh, like here?
Yeah, between, like prior to that statement.
Oh, like what you could do is something like this, like this with an empty string. Yeah. Actually, let's see how that behaves. Oh, it didn't do it. That's. Oh, well, I'll put a space in. Oh, can't separate those because that's how the error function behaves. Although I might have another way to defeat this. This is like similar to C, a new line character. I believe it should honor this. Let's find out. Oh, nope, didn't. Okay. Never mind. But there may be a way like using sprintf or something like. Oh. I'll show this thing. Bow to my will. Okay. Whoops. Okay. All right, so what's happening here is this is for formatted output. So this is the same kind of formatting conventions for producing formatted output in C or C++. So here it puts in a new line character, and then it'll use error. Okay. It's giving me a warning, but I'm not going to worry about that now. Ha! Okay, that works. There's almost always a way. Okay. Yeah, so this gives me a string that has a blank line followed by the message. So that way when that is passed to error, it has to print the blank line. Apparently what this, I don't know if you can see, it's underlined, it's giving me a warning. It says I could have done this directly, but I'm not going to look into the details of that right now. This is too much of a digression as it is. Okay. Let's see where we're at. Okay. I have another function M file to show you. Okay, this one's more interesting because it has multiple inputs, multiple outputs, and different behavior depending on how many outputs are specified. So the job of this function, vec_angle2, is computing the angle between two vectors. So you give two vectors, so x and y are soon to be vectors, and the output will be the angle between them, using techniques that I believe are taught in Cal 3, in radians and degrees, so both formats. So there's some idiot proofing or error checking done up front. So first, this function, length, very useful function. Gives you the number of elements in a vector. So it's best to use on vectors as opposed to matrices. There's a size function for that. So we get the length of x. Now to compute the angle between two vectors, these vectors should have the same number of elements. So we check, is the length of x the same as the length of y? If they're not equal, error message. So we're going to abort at this point because the operations that follow would not make sense. Now, the angle between two vectors, what you do is you take the dot product of those vectors. So to do a dot product, x transpose y is a dot product. And that's also the correct dot product if these were complex. So it'd be a Hermitian transpose in that case. So x transpose y is a dot product. And then norm is a Euclidean magnitude of a vector. If x is a vector, so the norm of x is a magnitude, the same magnitude you learn in calculus, like square root of a sum of squares of the elements of a vector. So then, the dot product of two vectors divided by their magnitudes is known to be equal to the cosine of the angle between them. So now we just need the angle itself. So if we have a cosine, we evaluate inverse cosine. So the inverse trig functions are known as, in MATLAB, as a sine, a cos, a tan, like arc cos, arc sine, but it's just the a. So a sine, a cosine, a tan, those are the inverse trig functions. So we take arc cosine. Now the trig functions, both the regular trig functions and the inverse trig functions, all assume radians. So cosine or sine expects an input of radians. Arc cosine or arc sine would give an output in radians. So that gives us the angle between the vectors in radians. And then for the angle in degrees, we just convert to degrees, multiplying by 180 over pi. But there's one very important point I want to make, because with this if statement right here, n arg out. Because n arg out is a special variable in MATLAB. It's the number of output arguments that the user actually requested. Now, for this function, you can request up to 2 outputs. So it could be 0, 1, or 2. It cannot be more. So n arg out is how many of you actually specified. So only if the user, when they called this function, wanted 2 outputs, do we bother doing this, actually converting the angle to degrees. Otherwise, it won't bother. So there's also n arg in, the number of input arguments that the user actually specified. So now that is useful for having certain arguments be optional. So for example, suppose you have a write a function that has 5 input arguments, but you want the last 2 to be optional. So what you can do is you can check if n arg in is less than 5 or less than 4, then you can assign those arguments default values. So it's a way of making those optional. So functions can be written very flexibly using n arg in and n arg out. So I'm going to call this function showing you the usage. So I'm going to make 2 vectors in 3-dimensional space, make them the same length, or same number of elements. Okay, so for instance, here's what I can do. Vec angle 2, xy. So here, I specified no output arguments. So when that happens, only the first output is returned and is stored in ANS, sort for answer. We've seen that before last week. So that's the no output case. Now I'm going to specify angle in radians, 1 output. So now whatever variable I give, that will get the output value. And because n arg out was only equal to 1 in that case, so it didn't even perform a computation to convert the angle to degrees. Now I'll do 2 outputs, angle in radians, angle in degrees. So this is how you specify multiple outputs. You put them in a comma-separated list and close in square brackets, which is just like how they're shown here. It's the same syntax. So now I go ahead and do that. And there's the angle in radians that we've seen. Same angle in degrees. So notice when you have multiple outputs, it will print out all of them, since I didn't put a semicolon here. Okay. So, questions about this one, or this code, or any of the statements in it. Okay, so yeah, it's an example of a function that has quite a few statements, far more elaborate than the first one I showed you, converting temperatures. So for example, I compute dot product here, so that value will stay active if I were to use it anywhere in this function. Alrighty.
So that is the code. Where do you enter the input to run the function? Because I enter it here in the command window and it don't run.
Yeah. So here at the prompt is where the command window is where I would do that.
So don't you got to write the name?
Okay.
The function and then the input.
Well, now, do you have this file?
No, I don't have that. I was running the.
I'm going to post it on the site later.
Yeah, but the one that you had first with the temperature, I was trying to run that one.
Okay.
But you input the 212. I didn't get a value out.
So what did it do?
It just said empty transfer function. Answer equal empty transfer function.
Empty transfer function?
Yeah.
That's.
I don't know what I'm doing anyway.
That's.
So
Well,
if it comes out like that, that is because why? I'm just trying to figure it out.
Oh well. Okay, so now okay, I'm gonna remove this for a second. So you had this code here.
Yes, I have all of that.
Okay, and you called it for similar,
just like
that.
I put the 12 in it, and I put the 212 in it just like that.
Okay.
And but you put it in the same window in which you in.
Okay. Okay. So I typed this code here in the MATLAB editor, and then saved a file, convert temp.m, and then I'm calling it from here in the command window.
So let's go here. There. I have all that. So I have all that. I run it. So it's fine. I'll just mess with it some more. It's okay. I'll just mess with it.
Oh, something was missing there? Or
No, I'm saying I'll just mess with it some more because.
okay. Yeah. Well, if you still can't get it to work, definitely send me your function and see if I can spot something wrong with it or something else.
All right.
Okay. But I want to confirm. Is this the message you got? Is that what you said? Okay.
Yeah.
That's really strange. I've actually not seen that before. Okay.
Never done it before.
Okay, so
What is nargout? What is that?
what?
Nargout? That was,
Oh, and n-argout is number of output arguments.
okay.
Okay. That's really strange. Okay. Yeah, email me your file, your convert temp file.
Yeah.
Okay. All right. Yeah. So back to this function. While it expects 2, nrgout is set to the number of outputs actually given.
So how do you run this one? Whenever you do a function, you just call it and then
Um,
values for.
like that.
Okay, so you just call it the whole function.
Yeah, you can always do that, but you don't have to. Like this is valid also. So actually, what I'm going to do, I'm going to make it print out nrgout when I run it, just by putting it here with no semicolon. So now, if I call it this way, nrgout is 1. Whereas if I do it this way, nrgout was 0, because I didn't put anything here.
Can we just call the second output instead of the first output?
Right? Oh, you mean degrees or?
Yes.
Oh no, order matters. You know. So if you only put one of them, that's going to be the first one that's actually listed here. Yeah, because some languages have an option of named arguments, or arguments can be in any order. MATLAB doesn't do that. It's all about position.
That error vector length less degree.
Yeah.
So what would cause that?
Oh, if for instance, my 2 vectors x and y both had 3 elements. Suppose one of them had 4.
Okay. So where did you set them to have 3?
Oh, when I created them, x equals, and then y equals. Yeah.
Okay. So can we do that in the function?
In the function, I create x and y here.
Yeah. So we don't have to do that every time.
Oh, well, in that case, you wouldn't have these parameters then.
Okay.
So yes, you can. Yeah, so in that case, you're doing what's called hard coding those things.
Yeah.
Which you generally shouldn't do, but yeah.
Yeah.
Okay. Okay. Other questions? Okay. So this function, since it expects 2 arguments and uses them both, suppose I called the function this way. I only pass x. When it's wanting y, that's going to be an error. And because here it uses y, the second input, and it's not there. And MATLAB concludes that what happened was not enough input arguments. So now, suppose I do this, x, y, z. Oh, z is undefined, so that's a separate problem. I'll do y again. Too many input arguments. So with whereas if I do something like this, there's 2 outputs expected are up to 2. Oh wait, too many output arguments. So the number of inputs was okay, the number of outputs is excessive. So a function expects a certain number of inputs or outputs, can never exceed. You can have fewer. With output, it's definitely okay. If you have fewer input arguments than what's expected, it's fine unless it tries to use one of the ones that wasn't passed. Then that's going to be an error, and it'll tell you not enough inputs. All right, so those are things to be careful about with number of inputs and outputs that you specify. Okay. In the short time we have left, does anyone have any, well, besides any questions about this, further questions about the homework? All right. Well, yeah, it's already quite late. It's almost 8 o'clock. Now, as far as the rest of the tutorial is concerned, thankfully we're getting close to the end, but I think I'll be able to cover that on Thursday. It'll be a little more interesting, the graphics part. Okay, so as a reminder, as you work on the homework that's due in 1 week, be sure to go to the questions, see if your question has been answered already. If not, then by all means send it. Chances are it'll be of interest to the class, so you'll be helping yourself and helping your classmates. So please keep that in mind.